Today I'm going to walk you through an example of how to do a t-test. In this example, we're going to be looking at the average age in days of individuals of the species Daphnia longispina, a crustacean. The average age in days that they begin reproduction. And these were measured from two different populations. Our research question is, do the populations begin reproduction at different ages? The hypothesis is that population 2 reaches reproductive maturity later than population 1. To test this hypothesis, we've collected the age of maturity in days for 7 individuals from population 1 and 7 individuals from population 2. We're going to calculate the mean, and to do that, we'll calculate the sum of each population. We'll look at the sample size of each population, which again was 7. And so if we divide that sum by the sample size, we get the mean for each population. So the mean of population 1 is 7.5143, and the mean of population 2 is 7.5571. Then we calculate the standard deviation, and that should be S, not S squared. There we go. The standard deviation of each population, where the standard deviation for population 1 is 0.5047. And the standard deviation of population 2 is 0.4095. And remember, there's an easy way to do that using Excel. You type equals STDEV, open parentheses, and highlight the data you want the standard deviation of, and Excel will do the rest. So then if we want to test our hypothesis, we need to use a statistical test. And the test we're going to use here is the t-test. And so here's the t-test equation. If you don't remember it, we're going to take the absolute value of the difference between the two means, and that's divided then by a denominator that includes the standard deviation squared for population 1 divided by the number in population 1, plus the standard deviation squared of population 2 divided by the number in population 2. We take the square root of that sum, and that's the denominator for this calculation. So if we plug in our numbers into that equation, here's what we get. And if you then go through all the math, do all the calculations, ultimately we end up with a t-value of 0.1743. So now we want to use that t-value to find out if there's a statistically significant difference between these two populations. To do that, we're going to use our t-table. So here's our t equals 0.1743. And then remember, the next thing we need is to know which row in our t-table to look at. So we're looking for the degrees of freedom. And the note says the degrees of freedom is always the n minus 2. N is going to be the total number of all individuals. So we had 7 crustaceans in each population for a total of 14 minus 2 is 12. So our degrees of freedom will be 12. Now we're going to look here in row 12 in the degrees of freedom column. We're going to go across this row looking for our t-value, 0.1743. And we can see the t-values go up as you go across the table. And in fact, our t-value would fit right here in this row. We follow up to the top of the column to find our p-value. And in the p-value row, we can see whatever our p-value is, it sits to the left of a p-value of 0.75, and that means our p-value is greater than 0.75. We don't know what it is, but it's greater than 0.75. If you recall, our alpha value, our test value, is 0.05. In this case, our p-value is much greater than 0.05. It's greater than 0.75. And so that means we accept the null hypothesis. And we'll say we have a p-value of greater than 0.75, accept the null hypothesis. And remember that the null hypothesis is always that there's no difference, statistically significant difference between our two groups. So if we go back and look at our data again, we can see that small difference in the means that we wondered if it was statistically significant. We've concluded it's not. And so our conclusion would be there is no significant difference in age of maturity of the two populations with a t equal 0.1743, a p greater than 0.75, and degrees of freedom of 12. And that's an example of how you do a t-test.